Do those even look similar? You didn't start out with a 25-degree angle. Not even close. Trent, do you know how to use the protractor? Okay. Group 1 or group 3, what'd you get for DE? 2 centimeters?
It was 2.1, but like, you did.
2.1. Let's go with 2.1. Group 2, what'd you get for DF?
4.6.
4 point what?
4.7.
4.7 centimeters. Group 1, EF? 3.6 centimeters.
Yep.
Okay. What we're just going to do to make life easier is I'm going to use this. This is 43 centimeters. E prime to F prime is 33 centimeters. And D prime to E prime is 19 centimeters. Okay. Obviously, these are bigger than what you would get, since it's on the board. So, what would I need to do with those side lengths to figure out if those are similar? So take the image and divide it by the pre-image. So what could I take 43 and divide it by?
33.
This 33 from the pre-image? Nathan, is that the corresponding side? What's the corresponding side from the pre-image? 4.7. What is 43 divided by 4.7? Aiden. Those things can break. How about we stop doing that? Pick up a pencil and take some notes.
9.4.
Get what?
9.14.
9.14, so 1/4. Okay? So what's another corresponding side that I could, or corresponding set of sides I can check? So 33 divided by 3.6 gives me? Karen? 9.16? Do those look pretty similar? Those ratios? And then, what would 19 go with? To 2.1. What is 19 divided by 2.1? Jordan, no one needs to blow their nose as much. Come on, dude. What do you get? 9.04? Let's try the 19. What do you get? No, 2.1 is better. Okay.
Already cold.
So, let's look at those ratios. Those ratios all seem to be about the same. What's the P word, Anaya, I'm teaching? What is the P word that tells me that the ratios are all about the same? Raise your hand.
Raise your hand.
Proportional. The ratios are all about the same, so those sides are proportional. Yes, ma'am.
So I did those like yours.
Yes.
Okay, well I said
It'll be different, but what should be the same?
all the
Well, all of your scale factors will be the same.
why not like this
Because all of your scale factors will be the same. So, hey guys, hear me clearly on this. You will not get the same ratio that I did. Again, you will not get the same ratio that I did. But all of your ratios for the image to the pre-image should be the same. All of your ratios of image to pre-image should be the same.
Wait.
Okay.
Oh, you got a
So number 3, okay, I want to point this out because this is where I got the idea to do what we did. Actually, we need to answer number 2 first. Are the two triangles similar?
Yes. Yeah.
All the sides were what?
Congruent.
Not congruent.
Ratio.
Proportional. Remember, when the ratios are the same, it's called proportional. So all the ratios are the same, so they're proportional. And all the angles were congruent. Okay. So were these triangles similar? Yes. Did I say congruent or similar? I said congruent, didn't I? What did I mean to say?
Similar.
Yes, the triangles are similar. Those are very clearly not the same size, but the triangles are similar because sides are, what's the P word for the sides? Proportional. And angles are what? Jordan. What are you doing? Are you attempting to take notes? And the angles are what? Congruent. Congruent. Thank you, Emily. But here's the thing, Taylor. I'm not over there. Focus up here to one and take some notes. Do we need to, or do we want to have to check if the sides are proportional and all the angles are congruent every time?
No.
I have zero desire to do that. And so that's where question 3 comes in. Question 3 says, in triangle DEF and triangles D prime, E prime, F prime, 2 pairs of corresponding angles are congruent. In fact, to make your triangles, how many angles did you actually pay attention to? You only did 2, didn't you? The 27 and the 25 degrees and the 47 degrees?
Yes.
Those are the only angles that we used. And using 2 congruent angles, did we create similar figures?
Yes.
Yes. So is it enough to have just 2 congruent angles to know if the figures are similar?
Yes.
So in triangle DEF and triangle D prime, E prime, F prime, 2 pairs of corresponding angles are congruent. Determine whether this is sufficient information to conclude that the triangles are similar. Yes. And here's an important thing I do want to remind you of. Okay. In similar figures, what are always congruent?
The angle.
The angles, right? And if I know in a triangle that 2 angles are congruent, what do I automatically know about the third angle?
That they're also congruent.
Don't the third set of angles also have to be congruent? Because the angles all have to add up to
180 degrees.
180 degrees. So if 2 angles are congruent, all 3 angles are congruent, so the triangles are
Supplementary.
not supplementary, similar. If 2 angles are congruent, the third angle has to be congruent to add up to 180, so the figures have to be similar. If 2 angles are congruent, then the third angle has to be what? Or the third pair of angles. Okay, then the third pair of angles have to be what? Jordan? Congruent. So if 2, and I should say 2 pairs of angles are congruent, then the third pair of angles have to be, or no, third pair has to be congruent. So the figures are similar. Notice how I use that symbol for similarity, right? The figures are similar. If two pairs of angles are congruent, then the third pair of angles has to be congruent. So the figures are similar. Okay. Does anybody have an idea what the theorem might be called? Okay, first off, it's definitely going to be a similarity theorem. What two things had to be true?
Similarity angle theorem.
We had to have how many pairs of angles? We only had to have two, right? Because the third automatically had to be congruent. So it is only called the angle-angle similarity theorem. Box this and pay attention to it. This is important. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar, right? If two pairs of angles are similar or are congruent, then the triangles are similar. So notice, we only had to have these two pairs. Why is this similarity theorem the angle-angle instead of angle-angle-angle?
Because angle. Because angle is possible.
It's possible, actually. Remember, we just said it. If two are congruent, then the third is automatically congruent. So do I need to check all three angles? No. Hear me again on that. If two pairs of angles are congruent, the third is automatically, so I don't have to check the third. Okay? If two pairs are congruent, then the third automatically is. I'm erasing. So if two pairs are congruent, so that third pair is automatically congruent, so we don't need to check. So if two pairs are congruent, then the third pair is automatically congruent, so we don't need to check. You ordered for real alcohol again?
Great.
Okay. I have never had students struggle so much to keep things on the desk. It's mind-boggling.
Right.
That's the congruence. Okay. So, if two pairs of angles are congruent, then the triangles are similar. Not going to worry about that. So we're going to jump to number 5. Yes. Okay. So I do want you to pay attention to this number 5 here. Do we have enough information to know that these isosceles triangles are congruent? No?
No.
Huh?
Can you repeat that?
Number 5, do we have enough information to know that these triangles, or not congruent, that these triangles are similar?
No. I mean, they are, you said, what's the word? What's the word?
2 pairs of what? Congruent angles. So do we have enough information here?
No.
No. We don't. I will point this out though, because this matters for the next question. So we can't use angle, similarity. But there's 2 things to pick up here. You see how this side is congruent to this side?
Yeah.
Yo, hey, I need you to pay attention and try to take some notes. If he's distracting, ignore him. If you're just, I'm not done. If you're not paying attention, focus. Okay. Do we know what these 2 lengths are right now?
No.
No. So what can I use to represent something I don't know?
A question mark.
Yep, but we're in high school math.
X.
Can I use a variable? X would represent a length I do not know.
No.
Would that X show up anywhere else in these figures?
No.
You sure about that? Where? What other one? Not the corresponding side. The congruent side, right? Isn't LM congruent to MN? So if this is X, this is also X. That's important to pay attention to.
Yeah.
Now, can I use X over here for PQ? Nope, I already used it. So what could I use instead? I can use PQ. I was going to say Y. Would that Y go anywhere else? On the other side for QR? Whoops, not. What did I say? Not me. So, hear me very clearly on this. Please listen. Notice how that means those 2 sets of sides are proportional. If I take the image length of Y, what is the corresponding pre-image length? Pre-image. X, right? If I look over here at QR, what is that length? Y. And what is the corresponding pre-image length? X. Are those 2 ratios the same? I have no clue what those lengths are, but those 2 ratios are the same, aren't they? So what's an important P word? They are proportional, right? Those ratios are the same, so these are proportional. But here's the issue. How many pairs of sides do we need to be proportional?
2.
Pairs of sides. We need all
3.
3 pairs of sides to be proportional. How many angles did we need?
2.
2. Okay? So pay attention to that. Now, if I look over here, though, right, we can't use angle similarity. We don't have any more information for number 5, but we do have some information for number 6. I'm going to make something up. Okay? So please understand, I'm making this up. Let's say that this angle measure is 80 degrees. That would also be 80 degrees, wouldn't it? Can I find any more information out about those angle measures?
No.
Sure about that?
You can try.
No, I definitely can.
Yeah, effort is the best policy.
If you weren't aware of this, angles that are opposite congruent sides are also...
Congruent.
Please hear me clearly on this again. Angles that are opposite congruent sides are also congruent. So you see how this side is congruent to this side? So these 2 angles have to be congruent. So these angle measures have to be the same. What would these have to be so that everything adds up to 180? That's not the time to ask right now. Ask me before class or after class. Yes, ma'am. If I do 50 and 50, does that give me 180? 50 plus 50 is 100, plus 80 is 180, okay? If you weren't sure You can use some algebra to figure it out. Because remember, what can we use to represent something we don't know?
X.
A variable, an x, any variable really. So notice I could do x, and I know that those three things have to add up to 180. Right? This is some simpler mathematics that you have done in middle school that you can use here. But notice Lillian could see it right away. If you can see it right away, you don't have to do the algebra, you just have to explain it. But notice, if I do 80 minus 80, I get 0. Right? How can I rewrite x plus x?
X squared.
Not x squared. X squared is x times x. This is
2x.
2x is equal to 180 minus 80 was 100, right?
So 2x equals 100.
Well, 2x equals 100, but we're multiplying here, so what's going to undo multiplication?
Division.
2 divided by 2?
0.
1. Anything divided by itself is 1. 100 divided by 2 is?
50.
Does that agree with exactly what Lillian said?
Yeah.
So notice you can do this algebraically, or you can just see it right away. So, are these two figures similar?
No.
Well, sorry, I forgot to finish this statement. This is 50, right? This is 50. What do these have to be?
50.
So are those figures similar?
Yes.
Yes. And this leads us into an important detail, okay? We didn't originally have these sides, did we?
No.
No? But VW to ST, if we do the same thing as earlier, that's Y to X, right? And this is also Y to X. If two sides are proportional and the included angle is congruent, any guesses what those triangles might be?
Congruent.
Not congruent, say again. Similar. Remember, Joey, it's okay. The whole thing is that the ratios are proportional. Those side lengths are not the same, so they can't be congruent. But if the ratios are proportional, then they could be similar. Notice how we have two sides that are proportional and the included angle is congruent. Anybody know what the similarity theorem might be called? We have two sides and the included angle.
Oh, sass.
Would SAS or side angle side make a little bit of sense there? Yes?
Sassy.
Okay. So apparently that's not till activity 2.3. I jumped a little ahead. Okay, so what I am showing you is activity 2.3. I'll come back to 2.2 in a second. So jump to activity 2.3. Okay. Notice if two of the corresponding sides of the two triangles are proportional and the included angles are congruent, the triangles are similar. Okay? That's the side angle side similarity theorem. Notice that's different than the congruence theorem. For the congruence theorem, the two pairs of sides had to be what? Congruent. The included angle had to be congruent. And if that was true, the triangles were congruent. Here, if the sides are proportional and the angles are congruent, those figures are similar. Okay. Side angle side. We don't have time to go through it, but you better box that and you better know what the side angle side similarity theorem says. Activity 2.2, it says SSS similarity theorem. Any guesses what SSS similarity theorem might be about?
Sides, three sides.
The three pairs of sides need to be what?
Proportional.
Proportional, right? So remember, those ratios of the sides need to be the same. They need to be proportional, right? And so, where is it? No? Man, the dude is sawing logs over there. Apparently, I don't have it in the slide, but I assume it's somewhere in the book. Yeah, I don't know how I missed this slide when I was copying it over, but the side similarity theorem says if all three corresponding sides of two triangles are what? proportional, then the triangles are similar. Highlight that and pay attention to that as well. You need to know that similarity theorem. So, go ahead and flip to the practice really quickly. We're going to wrap up with a couple of practice problems. This is on page 33 and 34. Whoops. So looking here at page 33, A. All right, practice number 1 says determine if the triangles in each pair are similar. Does anyone see anything in A that would tell you those two triangles are similar? Peyton? The 90-degree angle? Okay. Does that one set of angles tell us they're similar though?
No, I forgot the name of it.
The congruent symbols?
Yeah.
That's all it is. The angle congruent symbols. So how many angles do we have congruent? 2. So what similarity theorem can we use? Angle. I thought we just had 2 angles, right? So we're using angle similarity theorem here. We don't know what those measures are, but we know that those 2 pairs of angles are what? The pairs of angles are congruent. Remember, the triangles are similar, but the angles have to be congruent. What about B? We have 2 pairs of angles, right? So what can we use for similarity? Angle similarity. Let's look at C. Are those going to be similar triangles?
No.
I'm aware. Actually, really quick question. Hey, if this is 100 and this is 60, what does this angle have to be? Are they similar?
Yeah.
So notice we might have to use that information to find the third angle, but we can now tell angle similarity, right? Well, remember, dilations create similar triangles. In fact, all of these have dilations. All right. D, again, what are we looking at? Angle. Nope. Look at E. What can we use for E? Do I have an angle for big E? So I'd have to use side, and check the proportionality. Does anybody know what 4.5 divided by 3 is? No. Okay, pick up a calculator. 1.5. Check 3 divided by 2. Yo, we're not done. 3 divided by 2 is? So, do all of those sides have the same ratio? Yes. So, can we use side similarity? Yes. What would we use for F here? Side, angle, side. The angles are congruent, right? What is 6 divided by 2? 3. What is 9 divided by 3?
You say 3. Oh, I'm sorry.
You're good? So the sides are proportional, the angle in between is congruent, so are those figures similar? No. Side, angle, side. Okay. For those who do not have their book, you better have that book tomorrow. Have a great rest of your day.
Give me my phone. I don't know what it is.
So here's information about doing test questions on.
I don't even know what
I did give out your what? Dude, I'm not going to give you whatever to make your grade go up. I will give you stuff when I get to it of the things that you're missing. But then you slept in my class today. Why am I going to help you out if you're not even trying to stay awake? Dude, that's always an excuse. Okay, Jordan, you still need to make up this test. Where are the tests that I had yesterday?
I was gonna say, if you can't find it, can you give it to me?
Do you ride the bus?
Yes, sir.
Yeah, get out of here, I'll give it to you tomorrow.
Okay.
I had it somewhere.
But I can keep this stuff right, Mr. Kenny?
I think I found it, hold on. Yes. Those are notes to help you do test corrections. Here's all my tests, dude, you haven't taken one of your tests.
Dude, I'm about to go out here.
You didn't take the Unit 4 test.
It's
Here's
actually,
Unit 3.
because I was here. Cause you didn't get everything you were leave.
When what?
I said, I remember taking it because, yeah, I did take it.
That's Unit 3. I don't have your Unit 4 right here. I'll have to look for it. But you can start on those test corrections for now.
Okay.
Like, that'll be plenty for you to work on.